Good morning, everyone, and welcome to Wednesday, April 1st. So today, if you've been checking the calendar for Algebra 1, we are going to learn the final stage of factoring, which is factoring a trinomial that has a leading coefficient greater than 1. However, to begin, we're going to start with kind of a three-part warm-up. And in the warm-up, we're going to go over the three types of factoring that we have learned so far in our distance learning. So feel free to follow along. Each warm-up will have two problems, and I'll go over both of them. One of the problems, at least, will be a type that you have struggled with from what I can see on your IXL practice and from what I can see in the survey that you have filled out with regards to your worksheet practice. So get your paper and pencil ready, and we'll start with our first warm-up. Okay, so the first part of our warm-up, we are going to practice factoring using the GCF. GCF, again, standing for greatest common factor. So this means of all the terms that you see in the expression, find the greatest possible number, including variables, that goes into both, and then factor that out and basically use distributive property in reverse. So in the first one, we're going to practice this using a binomial, negative 32a to the fifth minus 24a squared. Keep in mind that the leading coefficient of this one is a negative, and I mentioned yesterday and on Monday what to do when you have a leading coefficient of a negative. So just keep that in mind. In the second one, we're going to factor out the greatest common factor of this trinomial, 36x cubed plus 8x squared minus 24x. Go ahead and pause the video now if you want to try this on your own. And here we go. So I start by looking for the largest possible number that goes into 32 and 24. I happen to know that that number is 8. Now, if you remember, when the leading coefficient is negative, that means I'm not going to factor out a positive 8. I'm going to factor out a negative 8. So the first step, if you do this the long way, is to start by writing both of these as products using negative 8. So in this case, negative 32a is negative 8 times positive 4. That's how I get negative 32. And then a to the power of 5 just means a times a times a times a times a. 1, 2, 3, 4, 5. That's basically the product of the first term. Then in the second term, so here's the first term. The second term using negative 8, negative 24a. Now notice I am including this subtraction sign with that term. So I'm thinking about it as a negative 24a. Negative 24a is negative 8 times positive 3, and then a squared, excuse me, I think I said a earlier, is a times a. So you could call this step expanding the product, you could call it factoring out and rewriting the product, whatever you want. Now we look for what do they have in common. Well, we know that they have negative 8 in common. That's a given, and we already knew that because that's the greatest common factor of 32 and 24. But you also have to look at the variables and see what do they have in common. They have a times a. And a times a is a squared. So after you look at for what they have in common, that is the GCF. That's the greatest term that they have in common. So here we go. Now we're going to write both of these. Now in the previous notes, I would then write both of these as products and then factor out the GCF, but we've been doing this enough now where I'm going to skip that second step and go straight to factoring out the GCF. So I'm going to take out negative 8a squared from both terms. So when I do that, I'm going to be left with a binomial inside of a group that where the first term is what do I have left when I take out negative 8 squared, and the second term is what do I have left when I take out negative 8a squared. So when I take out the negative 8 and the a squared from the first term, I'm left with 4 times a times a times a, which in other words is 4a to the power of 3. When I factor out negative 8a squared from the second term, here's where we make mistakes. I'm left with a positive 3. Now, would I write that like this? That doesn't seem right, because a negative 8 times a negative 3 would mean this is addition, and it's not addition, it's subtraction. So when you have a positive 3 remaining, you're going to leave that, represent that using addition. So the factored form of our first problem is negative 8a squared times the group of 4a cubed plus 3. And that is your final answer. To check it, we would just use the distributive property and quickly multiply to c. Negative 8 times 4 is negative 32. A times a times a times a times a. So 2 over here, 3 over here means a to the 5th. So I know that these two multiply to the first term. Negative 8 times 3 is negative 24. Bring along the a squared. So I checked this mentally, and I know it is correct. Let's take a look at the second one here. So for this one, we have 3 terms, 36x squared, 36x cubed, 8x squared, and 24x. So first, I think, what's the greatest common factor of 36, 8, and 24? And I happen to know that that is also 8. 4, excuse me. 8 goes into 24, but 8 doesn't go into 36. 4 goes into 8, 24, and 36. So pardon my mistake. The greatest common factor here is 4. So I'm going to do the same first step over here, write each of these terms as expanded products using 4. So 36 is 4 times 9, and then x cubed is x times x times x. That's the first term as a product. The second term, positive 8, is 4 times 2, and x squared is x times x. And this 24 is 4. Well, and again, if we want to keep it consistent, we'll look at that as a negative 24. So that's 4 times negative 6 times x. So we're keeping it consistent with what we said over there. We're looking at that as a negative 24. Move that a little closer so you can see it. Okay. Now, what do they have in common? Well, obviously they have a 4 in common. We already knew that because that's the greatest common factor of 36, 24, and 8. But they also have an x in common, but only one x in common because this doesn't have more than 2. That means our GCF here is 4x. So we're going to factor out 4x. And then in a big group this time containing, it looks like it's going to contain 3 terms. Now here's what you'll notice. If you started with a binomial, you're going to end up with a product that still has a binomial inside of a group. That's how GCF factoring works. Same thing here. If you started with a trinomial and all you're doing is factoring out the GCF, you're still going to have 3 terms inside that group. So none of the terms go away. All right, here we go. If I take out the 4x from the first term, that leaves me with 9 times x, which we write as 9x squared. If I take out the 4x from 8x squared, that leaves me with 2 times x. That's a positive 2, so that's plus 2x. And then when I take the 4x out of 4 times negative 6, again, we basically brought that negative in because we're thinking about this as a negative 24. That leaves me with minus 6. Notice again, inside the group is a trinomial because we started with a trinomial. Let's go ahead and do a quick multiply to check. 4 times 9 is 36. X times x times x, that's 3 total x's, is x cubed. So the first one looks good. 4 times positive 2 is 8. X times x is x squared. Second one looks good. 4 times negative 6 is negative 24. Bring along the x. All of this looks good, and we're good to go. So that was factoring out the GCF, and that was a code that we did last week in our IXL practice and in our worksheet practice. So good job on the warm-up. We're now going to move on to part 2. All right, warm-up part 2, we're going to factor by grouping. So this was the focus of this week. and what we went over on Monday and Tuesday. So for those of you following along, number 1, 24x cubed minus 8x squared minus 15x plus 5. Number 2, 14b, that's a b, cubed plus 35b minus 2b minus 5. The way that you can tell that this is a factor by grouping example is that it has 4 terms. You would never do factor by grouping in anything less than 4 terms because you have to be able to make 2 groups and each group has to have 2 binomials in it. So that's how you can tell if you're given something with 4 terms, you have to do factor by grouping. All right, go ahead and write these down. Pause the video now if you want to try these on your own. And here we go. So factor by grouping, in order to do this, if you recall, you have to be able to factor out with a GCF. The 2 of them go together. So step 1, it's called factor by grouping for a reason. Step 1 is put them into groups. Now I purposely chose problems with subtraction because I could tell on your IXL practice and on your worksheet practice, this is where we struggled the most. So I can't just put them straight into groups because I can't put groups around a subtraction symbol. So with that being said, our first step here in number 1 is I'm going to rewrite it, putting groups around the first 2, and then bringing that negative sign along with a 15x. So here we go, starting with group of 24x cubed minus 8x squared plus negative 15x plus 5. Again, that subtraction has to go with that term. Just making sure that I wrote it down right. Okay, step 2, GCF factoring, which we just did in warm-up part 1. So we're finding the GCF of each binomial. Okay, I'm going to do this in separate colors because I think that that'll help you kind of see the math a little bit differently. So let's start with 24x cubed and 8x squared. So 24 and 8 have 8 in common. Yes, I believe that. And they both have some x's. So let's see, 24 is 8 times 3 times x times x times x. And 8x is 8 times 1 times x times x. So we're doing the same exact steps that we just did in our last example. So what do they have in common? It looks like they have 8 in common and x times x in common as well. So that leads me to understand that the greatest common factor here is 8x squared. So I'm basically factoring out 8x squared from both of these terms. What is that going to leave me with? Well, when I take out the 8 and the x squared, that leaves me with 3x in my first term. When I take out the 8 and the x squared, oh, I forgot to mention this is subtraction. So technically you could think of that either as keeping subtraction or this is a negative 1. Either way, you're left with minus 1. So what we did there is exactly what we were doing in our warm-up part 1. Now, we're going to do the same thing over here. Thinking about factor by grouping, think ahead now. You know you have to have a common binomial factor. So whatever I factor out here, I have to end up with positive 3x minus 1. Otherwise, I can't do any factor by grouping. That's why when the leading coefficient is negative, you have to factor out a negative. If I don't factor out a negative here, I'm going to be left with a negative term plus a positive term, and that doesn't match this structure. So here we go. What is the greatest common factor of negative 15x and 5? I know that negative 5 goes into both. So this would be negative 5 times 3 times x, because I know that negative times positive is how you get that negative. And negative 5 times what is positive 5? Negative 5 times negative 1. A negative times a negative is how you get that positive. So it looks like they both have negative 5 in common. So that's what we'll factor out, negative 5. And then what are we left with? We're left with positive 3x in the first term, which we wanted, which is already looking good, and negative 1 in the second term, which is again what we wanted. Now, from the questions I've been receiving from you, it sounds like this last step is the step that you are struggling with the most. Hopefully using two different colors will help you see it. We have not fully factored yet. What we've done is we've done the last step leading up to fully factoring. We've taken out the GCF, but we haven't put it into an actual product. So the first thing we're going to do is take out our common binomial factor, which is 3x minus 1. Because if you have something in common, that can go out in the front. We already know that from here. These had 8x squared in common, so we put that in the front. These had negative 5 in common, so we put that in the front. These both have 3x minus 1 in common, so we put that in the front. 3x minus 1. Now, here's where I'm getting a lot of questions. What are you then left with? Well, once we take out the 3x minus 1, what you're left with is a second binomial. That second binomial is a combination of the two GCFs. So over here, that's 8x squared, 8x squared, and negative 5. So my second binomial is the combination of the two GCFs. So my final answer here is 3x minus 1 times 8x squared minus 5, or you can flip these two and put 3x minus 1 after 8x squared minus 5. That's also totally fine. All right, normally I would multiply to check, but I don't want this video to run too long. So I'm just gonna check and make sure, yep, I checked my answer key that I had from my previous worksheet practice, and it looks like we're good to go. All right, warm-up question number 2 from factor by grouping. I chose this one again for a reason because it has subtraction, and then there's something a little weird about how we factor out with negative 2b minus 5. So here we go, step 1, called factor by grouping for a reason, put them into groups. In the first group, we have 14b cubed plus 35b squared. That negative goes with the 2b, so this is plus negative 2b minus 5. All right, step 2, GCF factoring. So what's the greatest common factor of 14 and 35? That would be 7. So this is 7 times 2. B cubed is b times b times b. Positive 35 is 7 times 5. B squared is b times b. What do they have in common? They have 7, and they have b times b, which we know is b squared. So the greatest common factor of these first two terms is 7b squared. When I factor out 7b squared, what am I left with? Well, when I take out the 7 and the b squared, I'm left with 2b in the first term. When I take out the 7 and the b squared, I'm left with positive 5 in the second term. So all I've done is GCF factoring of the first binomial. Let's take a look at the second binomial. Now this one is weird. Why is this one weird? Well, what is the GCF of negative 2 and negative 5? There isn't one. Negative 2 is negative 2 times 1, and negative 5 is negative 5 times 1. Wait a minute. What goes into everything? 1 goes into everything. So all we have to do is factor out 1. Okay, so this is negative 2 times 1 times b, negative 5 times 1 times b. So when I factor out 1, what is that going to leave me with? Let's see, that leaves me with negative 2b. Oops, this isn't a b. Negative 2b minus 5. Okay, so now we're good to go, right? Our common binomial factor, wait a minute, these aren't the same. That means I made a mistake. If these are not the same, a mistake was made, and I bet you know what my mistake was. If the leading coefficient is negative, what do I have to factor out here? I have to factor out a negative. So let's try that again. So even though 1 does go into -2 and -5, because this is a negative, I need it to turn into something like this. I have to factor out a -1. So this would be -1 times 2 times b, and -5 would be -5 times, oops, excuse me, -1 times 5. All right, let's see if by factoring out -1, I avoid making that mistake. So this is -1. And then when I take out the -1 from the first term, that leaves me with a positive 2b. All right, already I'm looking better. And when I take out -1 from the second term, that leaves me a positive 5. Now I can continue on because the common binomial factor is there. So remember, when they have something in common, you can take that out and put it in front. You can factor that out. That's a common factor. So in our final answer, my first binomial is 2b plus 5. Remember, just like we did up here, once we take that out, we just look at, well, what do we have left? I see a 7b squared minus 1. And double check with my answer key. Yes, this is correct. So this is factor by grouping. Again, only when you have 4 terms, start by putting them into 2 groups, factor out the GCF, get that common binomial factor, factor it out, and then whatever you have left. All right, warm up part 3 coming right up. All right, warm up part 3, our final 2 questions of our warm up. This was called factor by P's and Q's. So how do we know that we're supposed to factor by P's and Q's? There's 2 things that we now know. If you're given a trinomial, that's your first hint. So if you're given a trinomial, meaning a polynomial with 3 terms, and the leading coefficient is 1. Notice that this is a lone r squared and a lone n squared. So when you're given a trinomial with a leading coefficient of 1, you can do factor by P's and Q's. Now, it's been a while since we've done this. So let's take our time going through this, and then we might do a couple more examples, because you have to be able to factor with P's and Q's in order to factor in what we're going to do later today. So here's how this works. If you remember, feel free to pause and do this on your own if you want. Our answer is going to be a product of 2 binomials. So I can set up my answer. I know my answer is going to be, a little too far down, a binomial times a binomial. That's what I know. A binomial times a binomial. That's what I know. I also know that the first term in each of these binomials is what times what is the first term here. So what times what is r squared? That's going to be r times r. What times what is n squared? That's going to be n times n. So I've already halfway done. Like, I figured out the first term in each of my binomials. Now the second term has to be what times what is the last number, because if you're multiplying the first terms to get the first number, if you multiply the last terms, you'll get the last number. Same thing, first term to get the first number, last term to get the last number. But there's a lot of different ways to multiply 2 numbers and get -20. There's -4 times 5, there's -5 times 4, there's -2 times 10, there's -10 times 2, there's -1 times 20, there's 20 times -1. Which one is right? Well, that's where the P's and Q's game comes in. It's find 2 numbers that have a product of -20. So what times what equals -20, but also have a sum, that's a sum of +8. Because the 2 numbers cannot just multiply to -20, they also have to add up to the middle term +8. So now that's going to eliminate some of our options. So let's try 4 and -5, for example. Well, 4 times -5 is -20, but 4 plus -5 is -1. That is nowhere close to 8. So we know 4 and 5 are out. Let's try 10 and 2. So let's try -10 and +2. Negative 10 times positive 2 is negative 20. Negative 10 plus positive 2 is negative 8. So we're close. How could we make that positive 8? What about 10 and negative 2? Let's see. 10 times negative 2 is negative 20. 10 plus negative 2 is 8. That works. So that means that our second terms here are positive 10 and negative 2. Now, would it also work if you switch them? Yeah. Negative 2 times 10 is still negative 20, and negative 2 plus 10 is still 8. So we can totally switch these and it would work just fine. And we're done. That's the nice part about factoring using P's and Q's, is that we have R plus 10 and we have R minus 2, and we're done. Now, because that was so short and so quick, we're going to multiply to check it. So over here, I'm going to make a little quick box or window. Across the top, R plus 10. Down the side, R minus 2. Let's go ahead and multiply to check this real quick. R times R is R squared. That's the first term, already looking good. R times positive 10 is 10R. R times negative 2 is negative 2R. And negative 2 times 10 is negative 20. So already I see R squared and negative 20 as my first and last term, which is awesome. But where's the 8R? Where is the 8R? Ah, the 8R comes here from combining these like terms. So when I pull this expression out, that leaves you with R squared. 10R minus 2R is positive 8R, and end with negative 20. Is that what I started with? Yes. So I know my answer is correct. That is called P's and Q's factoring. Only works on a trinomial when the leading coefficient is 1. So let's try our second example here. Same idea. We know n times n is n squared. What times what equals 90, but adds up to negative 19. Whoops, lost my pen there. All right. So what two numbers have a product of 90 and a sum of negative 19? So let's try to figure that out. What times what equals 90, that when I add them equals negative 19. What could it be? 9 and 10 come to mind. So I know 9 times 10 is 90. And 9 plus 10 is positive 19. But I want negative 19. But I feel like I'm so close. Okay, what if I made one of them negative? Well, then negative 9 times 10 is now negative 90. And that's no longer negative 19. What do I do? What if I made both of them negative? Negative 9 times negative 10 is 90. And negative 9 plus negative 10 is negative 19. So there you go. My two numbers are negative 9 and negative 10. Because negative 9 times negative 10 is positive 90. And negative 9 plus negative 10 is negative 19. Let's check it just for fun, though. Just for funsies. Make a little window. Across the top, n minus 9. Down the side, n minus 10. And here we go. N times n is n squared. Negative 9 times n is negative 9n. Negative 10 times n is negative 10n. And negative 10 times negative 9 is positive 90. So already it's looking good because my first term is going to be n squared and my last term is going to be 90. But where's the negative 19n come from? That comes from combining my like terms. So when I pull it all out of the box, I'm left with n squared, negative 9n plus negative 10n is negative 19n plus 90, which is what I started with. So that means my final answer is correct. Now, what I'm going to do is I'm going to stop this video because this was mostly about a review of what we've learned so far. I'm going to attach some optional worksheet practice just going over this type of review. and then I'm going to start a new video on what we're learning today. So if you want to practice some of these skills before we do what we're doing today, go ahead and do so, and then you can tune in later on for the video about factoring using something called Flip and Slide.